So welcome back, and we're diving straight back into where we were, and this is we've got to draw this triangle. It doesn't really, I'll show you. It doesn't really matter how we draw it or where we draw it. Okay, there it is. There, I haven't drawn it very well at all, but suppose that's our 90-degree angle. That's angle B. We've got triangle ABC. This is little a. This is 6. Little c is opposite c, so this is 8. All right, and there's one side that we're trying to find, which is little b. Remember, the sides that make the right angle, square and add together, so 6 squared plus 8 squared will equal b squared. All right, 6 squared is 36, 8 squared is 64. They add together to give 100 is b squared. We want to square root both sides. We could write 10 equals b, but really it's better to write b equals 10. The units here are centimeters, 10 centimeters. Okay, right, now the next one looks like this, and we're going to draw our right angle triangle. Right, as I said, it doesn't really matter where we put that right angle. Okay, like that. Let's call this, the H is 90 degrees. It's triangle GHP. Okay, little p is opposite big P, it's 7. Little g is opposite big G, it's 9. And we're trying to find little h. Remember, the sides that make the right angle, that one and that one, square and add together to give us the third side. Okay, so h squared will be the same as 7 squared plus 9 squared. Right, so h squared will equal 49 plus 81. Now 49 plus 81 is 130. So h squared is 130. We're going to square root both sides to get our final answer. And I'm expecting something a little bit bigger than, in fact, a little bit less than 12. All right, because 12 squared would be 144. This is only 130. 11 squared would be 121. So somewhere between 11 and 12. Let's have a look. Okay, and we get 11,40. All right, remember the question asked for 2 decimal places. So 11,40. Let's go and check what the units were. They were centimeters. Okay, right. Sometimes, and there's some space there for you to make up some extra examples for yourselves. Your teacher can make them up or you can make them up. Sometimes we're given a picture and we need to sort of ask ourselves a question. So a boy is flying a kite on a string of 57 meters. How high is the kite above the ground? Now all of these questions have to have a right angle in them. And our right angle is there because the height of the kite above the ground will be perpendicularly straight down. We don't measure at an angle, we go straight down. Okay, so let's fill in what we know. We know the length of the string. This is the string over here. What is that? That is 57. Okay, what we don't know is the height. Let's call it h, and let's make an equation using Pythagoras. We're going to square the 30. We're going to square the other side that makes the right angle, which is the h, and we're going to get our answer squared. Okay, 57 squared. Right. So now, 30 squared is 900, plus h squared is 57 squared. I'm not sure what 57 squared is. Let's have a look. 57 squared is in fact 3249. Okay, 3249. 3249. We're going to subtract 900 from both sides, and that will give us, so minus 900. So we get 2349. And now to get the answer, we're going to square root both sides. Right, and remember that when we square root, we must square root both sides, so square root of our last answer, and we get about 48,000 48,47 meters. Excuse me. 48,5 meters. Okay, let's look at another one. Calculate the length of the diagonal of a rectangle whose length is 3 and whose breadth is 2. Right, I think it's going to be helpful to have a picture here. Okay, it's not an accurate picture at all. Maybe I could have made it a little bit better, but let's go with 3 and 2. And what we want is the diagonal. Now, the diagonal is this line over here. Okay, we need a right angle, but we are told that this is a rectangle, so we know that this is 90 degrees. All right, and now we can just use Pythagoras. Okay, let's call this D for diagonal. So we know that D squared, the two sides that make the right angle squared, 2 squared plus 3 squared is equal to the other side squared. All right, so 4 plus 9 is 13. So in fact, D squared is 13. Let's get D by square rooting both sides. All right, and remember that these were units. Okay, so we're not sure what they are. We're just going to say U for units. And let's just find the square root of 13. And we get 3,6 units. All right, the next question says, how long must a ladder be to reach a windowsill 6 meters high if the base of the ladder is 1,1 meters from the wall? Right, we need a right angle. And the right angle comes in between our floor and the wall. Okay, so there's a right angle in here. The windowsill is over here. All right, and our ladder is over here. Okay, so this is the ladder. We are told that the windowsill is 6 meters high. All right, and the floor, the base of the ladder is 1,1 meters away from the wall. Right, and so there's only one side we're missing, and that's the ladder. Let's call it L. So 6 squared plus 1,1 squared equals L squared. Right, 6 squared is 36. 1,1 squared is 1,21. All right, so L squared is going to be 37,21. All right, and let's have a look at this. I am just going to quickly check that I've got that right. That 1,1 squared is 1,21. I shouldn't need to check that. There it is, 1,21. All right, plus 36 is 37,21. And we're going to square root that, 37,21. All right, and we get a final answer of 6,1. So the ladder needs to be 6,1 meters long in order to reach the windowsill. Okay, right. This asks for the perimeter of this shape. Now, this is quite a cool question because it requires a little bit of work. Okay, to find the perimeter, the only thing we really need to know is this length over here. But in this triangle, we don't have enough information to find this length, all right? But this line over here is a bridge, ibilogo, a bridge, okay? And we can find the length of AC in the other triangle using Pythagoras, okay? And then we can use Pythagoras in this triangle to find the length of DC. Okay, so let's do that. Remember, the two sides that make the right angle square and add together. So 5 squared plus 11 squared equals AC squared. Right, so in fact, AC squared is going to be 25 plus 121. It's going to be 146. Now, you might say, well, let's work that out. Well, in fact, when we use Pythagoras in the next triangle, we're going to need AC squared. So I'm not even going to work it out, okay? I'm now going to go to the other triangle, and we're now going to say, well, and I'm just going to work next door here, which, okay, so we're going to go to here, and we're going to say 9 squared plus DC squared, all right, is equal to AC squared. All right, so I'm hoping you're seeing now why I didn't bother to square root AC. I don't need the length of AC. I'm just going to use the length of AC squared. So that's 146. This is 81 plus DC squared. Let's subtract 81 from both sides. All right, and we get 65. So DC squared is 65. All right, just checking that. Yep. Okay, and so we're going to square root both sides, all right, to get what DC is. DC is going to be the square root of 65, and we get 8, 1. All right, so DC is 8, 1. All right, now, the last thing we must do is we must work out the perimeter. And the perimeter is the whole way around the shape, not the inside. It's going to be 11 plus 5 plus 9 plus 8, 1. The perimeter is going to be 11 plus 11 plus 5 plus 9 plus 8, 1. 11 plus 5, I'm actually going to add those two together because I see they make 20. 25 and 8, 33, 1. And we weren't given units, so we're just going to write that the perimeter is 33, 1 units. Okay, right, we've left some space for extra examples. Right, but now the next thing we're going to look at is that we've got this idea of a converse, all right? And it's the first time we're encountering it, so we're going to just talk you through it. The converse of a statement is kind of the reverse. So if we say if A then B, the converse is saying if B then A, right? And sometimes a converse is true and sometimes it's not. So let's look at a one that is true. If lines are parallel, then the corresponding angles are equal. That's true, okay? Now the converse says if corresponding angles are equal, okay, that I'm going to underline that piece. That's that. All right, then, so we're just swapping the two underlined bits. Then lines are parallel. That's what we call the converse. Is it true? Yes, it's true. Okay. Okay, let's look at an example of one that's not true. If it is raining, then the road is wet. So what we're going to do is we're going to swap this underlined piece with this underlined piece. If the road is wet, then, so that's the one piece, and we're going to swap that, it is raining. Okay, is that true? No, this one's false, all right? And the reason it's false, it's not true, is because it doesn't mean that it's raining if the road is wet. Maybe it was raining a little while ago, or maybe even someone wet it with a hose. Okay, right. So let's look at what Pythagoras' theorem says. It says, if we have a 90-degree triangle, then the sum of the squares of two of the sides equals the square of the third side. The converse is going to be, if the sum of the squares of two of the sides. Okay, so that's all underlined. Is equal to the square of the third side, square of third side. Sorry, this is still all underlined. Then we have a 90-degree angle. Degree triangle. Okay. And so that's the converse. And the converse is true. Right. So we can use this to see whether or not we've got a right angle triangle. So let's test this here. So what we're going to do, we're going to take 10 squared. That's the longest side. And we're going to take 6 squared plus 8 squared. Now we're not going to put them equal to each other because at the moment we don't know they're equal to each other. This is 100. This is 36 plus 64. And this is 100. So because these two numbers are the same, yes, angle B is 90 degrees. And the reason that we would give here is the converse of Pythagoras. Okay, often we just shorten Pythagoras to Pythag. Okay? Right, let's test another one. So we're going to take the longest side. We're going to take 13,2 and we're going to square that. Then we're going to take the other two sides and square them and add them together. 5 squared plus 12 squared. Now 5 squared is 25. 12 squared is 144. We get 169 on this side. Alright? 169 is actually 13 squared. It's not 13,2 squared. Let's work out what 13,2 squared is. 13.2, and we're going to square that and we get 174,2. Are they the same? No, they're not the same. Is it a right angle triangle? No. Alright? Angle E is not 90 degrees. And the reason? Converse Pythag. So let's just quickly summarize that. When we've got a right angle triangle and we use Pythagoras, when we've got a right angle triangle, we can use Pythagoras' theorem. Right? When we've got a triangle, we can check whether it obeys Pythagoras' theorem, and that's where we're using the converse, and we are testing whether we've got a 90-degree angle. Okay, so we're going to stop there. We're going to ask you before the next lesson, we're going to ask you to look at, in fact, we're going to ask you to pause right now. We're not going to stop there. We're going to ask you to quickly try these two, and then we'll go over them, and that will bring us to the end of this topic. Okay, so this first one, we've got 8 squared plus 9 squared. Those are the two shorter sides, and we've got 12 squared. This comes to 144. This comes to 64 plus 81. 64 plus 81 is 145. Right, very close, but they're not the same. No. Angle Q is not 90 degrees. And our reason? Converse Pythag. Okay, and then the very last one, let's take a look. 18 squared is the longest one. 18 squared is 324. 15 squared plus 17 squared. This is 225. All right. And this is 17 squared is 289. All right. So definitely not the same. Okay. So therefore, no. Angle S is not equal to 90 degrees. And again, same reason, converse Pythagor. Okay, and guys, that brings us to the end of Pythagoras. Just quite a short module, but you'll see that we keep using Pythagoras in the future work that we do. All right, have a great day, everyone. We look forward to starting our last module in the next lesson. Bye.